Hello everyone, in Math 105, this is a video that is going to finish section 3.1 of our logic chapter. The section is deductive reasoning, and in the last lecture, we started talking about what logic is, and logic is representing different statements that can be either true or false, and what we're going to get more into today is what happens when you combine those statements into a single statement. For example, if I were to give you a statement, usually we represent a statement using a letter, like P or Q. So if I said statement P, represents it's snowing outside, that statement is currently true. That's a true statement. And if I gave you statement Q, I could say that statement Q represents class is canceled. So, and at the moment, that is true. So individually, those two statements are true. They're not false, they're true. In this video, we're going to look at what happens when we combine statements together using a connective word like and or. So if I were to do something like, if I were to connect them using the word and, that will be called a conjunction. So the conjunction would be, it is snowing outside and class is canceled. A disjunction would be connecting those using the word or. So a disjunction would be, it is snowing outside or or class is canceled. So we can combine statements together. And when we combine them together, we often try to look at whether that new statement would be considered either true or false. And it depends on what the individual statements are. So if you wanted to say it's snowing outside and class is canceled, if you use the connective word and, because both of the original statements are true, the new statement's going to be true. But if I were to change one of those statements to say something like it's sunny outside and class is canceled, well, sunny outside is false. So then if I were to try to combine those using the word and, that new statement would be considered false because one piece of it is not true. So this is what we're going to look at today, all the possible scenarios. And then there's also, when you use the word or, there's a lot of different combinations that we can look at. And what we do is we organize all these combinations into tables. We call them truth tables. And the truth tables you don't have to memorize, you just have to be able to use them and apply them to different scenarios to determine if these new scenarios, whatever they may be, would be true or false. So the next few slides I'm going to give you for you to copy down have all the possible scenarios, and then we're going to do some practice problems where we use these tables. Again, these tables are not things you have to memorize. You just have to understand them and know how we can apply them. So here's our first one. Here's a truth table for negation. So let's say we have a statement P, whatever it is. It's snowing outside, or I drive a car, whatever you want. Mickey Mouse is president. That's a classic one in logic. That one's always false, though. But whatever P is, the little squiggly sign with the P, that means not P. That means we want to negate it. So if you have a true statement, if you negate it, that's going to make that statement false. For example, right now I'm wearing blue jeans right now. So if I have a statement that says my jeans are blue, that's true. So if I were to negate it and say my jeans are not blue, that would be false. So when you negate a true statement, it becomes false. When you take a false statement and negate that, it becomes true. So negating something just switches it back and forth between true and false. So if I were to say my jeans are not blue, if I were to negate it to say my jeans are blue, then that would return it back to being true. So negation just switches back and forth between true and false. We have conjunction, which is and. The symbol for that is it's like an upside down V. And conjunctions are only true if both components, both original individual statements by themselves, are true. So here's a truth table for it. So truth tables represent all the possible scenarios that we can have. So when we build a truth table, what we always do is fill in the first column as true, true, and then false, false. And the second column is always going to be true, false, true, false. The first two columns of any truth table we do are always going to look exactly like that. True, true, false, false, and true, false, true, false. Because the goal is to look at all possible combinations of trues and falses. So if we just arrange our first two columns just like that, that allows us to look at every possible combination we can have with two statements, P and Q. So this is always how the first two columns are going to be. Now let's figure out the conjunction. Again, conjunction is combining two statements into a new compound statement using the word and. So if two individual statements are true and you combine it into a new statement with the word and, that entire new statement is going to be true. But if you have a true and a false together in a conjunction combined with the word and, that entire statement is going to be false. Same thing if you have a false and a true, that's going to be false. The only time a conjunction is true is if the two individual statements are true. And then if you have two false statements together combined into one new statement, that new statement is going to be false. An example of the last one, it's sunny outside. That is false. And what else could I do? There's a full moon. I'm hoping that's false also. I don't know for sure. But if you have it's sunny outside, oh wait, yeah, okay. If it's sunny outside and there's a full moon, those are both false statements. That entire statement together. It's sunny outside and there's a full moon. That entire statement is completely false because both individual statements are false. All right, and then we have the disjunction. That's where you combine two statements using the word or. The only time a disjunction is false is if both component statements are false. So on the next slide, and by the way, you can pause this video to copy this stuff down and rewind it, of course, if you want to listen to the explanation again. But if we want to do a truth table for disjunction, we're going to do true, true, false, false, true, false, true, false. That's how we always set up our first two columns, because that allows us to look at all the possible combinations of true and falses. The column all the way to the right is what we care about. So if we have two true statements combined in a disjunction, which means we're using the word or, the new statement, that new combined statement, is going to be true. And then if you have a true and a false statement in a disjunction combined with an or, that's going to be true. So an example of that is, what's an example? Let's go back to my shirt is, okay, my shirt is gray. That's a true statement. And my pants are purple. That is false. So if I were to say to you, my shirt's gray or my pants are purple, that's actually a true statement because of the word or. The word or requires only one of the statements to be true for the entire statement to be considered true. So when I say my shirt is gray or my pants are purple, that is a true statement because my shirt is gray. That is true. It's okay that I don't have purple pants. The entire statement is still considered true. If you have a false and a true, that's also going to be true. The only time a disjunction is false is if you have two false statements together. So combined, that would make them false. All right. So let's do some problems here. So the point of these truth tables is that we're going to use those statements, understanding the combinations of trues and falses, so that we can apply it to different scenarios. So here's our first one, A. So A is P and Q or not R. Now the directions say what is the truth value of the compound statement. Assume that P is false, Q is true, and R is false. So P is false. So what I'm going to do is I'm going to actually fill that in. I'm going to replace the P with an F for false. That way I can keep track of which statement's true, which one's false, so we don't get confused. And Q, according to the directions, Q is true. Or not. And then it's saying that R is false, so I'm going to write in false. So what I'm going to do now is simplify this. That's what the goal is, to simplify it to a single either true or false. That's what we want to figure out, if this entire statement is going to be true or false. So I'm going to start with the negation. I'm just going to do this one step at a time. The not false, if you go back to our truth table at the beginning for negation, if we have something that's already false and negated, that makes it true. Next, I'm going to do what's inside the parenthesis. Actually, I'm not going to write that. So in the parenthesis, we have true or true. We go back to the truth table we just did on the last slide. If you have a disjunction, true or true, that statement is going to be true. Now we're left with false and true. So that symbol right there is represents and. That's a conjunction. And when you have a false and a true together, let's go back to the table just to make sure. False and true. Great conjunction. That would be this one. So when you have a false and a true, P and Q, that's going to be false. So this statement right here is false. And that is our final answer. That is false. So the goal is to figure out what the entire compound statement is, either true or false. That's what our answer is going to be. And what we do is just replace each variable with its truth value, whether it's true or false, and then simplify it. Do the negations, do things in parentheses first, and simplify it until you get a final answer. Let's do example B. So not P or R. This one's a little easier. Not P. The direction said that assume P is false. I'm going to replace that with an F, and it says R is also false. So those are the truth values for it. Not false, the negation of not false makes it true. And then if we have a true or false, so that's a disjunction. Let's go back to that in the table. True or false. So if we have a true or false right here, and it's a disjunction, that means that the result of it is a true statement. So true or false is true. So true or false is true. And that's our final answer. All right, let's look at example C. So not P and Q or not Q. You definitely need to be able to tell the difference between the symbols, whether they represent and or, because that tells you which truth table to look back at. So not P, assume P is false, and Q is true, or not, and it says Q is true. I'm just going back to these descriptions up here. All right, so let's take care of the negations first. So not false is true. The negation just switches. Oh, I'm sorry. I didn't write. Shoot. All right, I didn't write this in. Q is true. I meant to write that. Um, or, so the negation of true is false. So there we are. So we have true and true. So true and true, if you go back to our conjunction table, I'll go back to that quick. When you have a true and a true, the compound statement, the conjunction is true. So a true and a true is true. There we go. So now this is simplified to be true or false. That's the symbol for or, which is a disjunction. True or false? Let's go back to our table. True or false is true. True or false is true. So what we need to be able to do is look back at these tables, kind of know where to look. That's going to be true. It's important to know the difference between what the symbols are, whether it's an and or an or, whether it's a conjunction or disjunction, because that tells you where to look in the tables and how you can simplify this. All right, let's do example D. So not P and Q. There's actually two ways you can do this. One of the ways I'll share with you in a moment, but let's just do it the way we've been doing all the others. Um, so P is false and Q is true. So a false and a true statement together. So that symbol is the connective word and. That's a um, that's a conjunction, and that would be false. Not false. It's true. So another shortcut is using something called De Morgan's law, which I do have a slide for at the end. It says you can essentially do distribution. You distribute your negative. You can think of it like distribution. Where the negation is, it's kind of like a negative sign. So if you want to distribute it, actually what you have to do is change the and to an or. And we'll see it actually works out to be the same thing. P is false. Q is true. So this is going to be true or false, and true or false is true. So actually you get the same thing. So two different ways to do it. You can do the distribution approach. If you do that, just make sure you remember to change the symbol. Or you can just do it the way we did initially. That's fine as well. All right, so here's a set of 4 more examples. If you want to try them on your own, feel free to. I'm going to go over them right now, but if you want, try them on your own and then check to see if you did them correctly with what I'm about to do. So here are the answers to this one. So first we want to look at the statement. P represents 3 is greater than 2. That is true. Q represents 5 is less than 4. That is false. And then R represents 3 is less than 8. So that is true. So the statement P is true, Q is false, and R is true. So that's what we're going to replace each of the variables with when we simplify them. So looking at the first one, so for A, we have not P and not Q. So we have P, we said was true. I'm going to replace that with the true. Q, we said is false. So I'm going to replace that with the false. And now we can start to simplify. Not true, switches it to false, and not false switches to true. So this is a conjunction. So false and true. That means it is a false statement, and that's your answer. For the next one, B. So for B, have not in parentheses P or not R. So P is a true statement. Let me back. So P is true, or and not R. R is true. So if we were to simplify that, true or not true is false. We have true or false. So going back to that's a disjunction, or true or false is true. So true or false is true, and not true is false. All right, so here's the next one. So we have, okay, for C, this is a longer one. We have not P and R, or not Q and not P. So I'm going to fill them in with the truth values. Not P, P is true, and R is true, or not Q, Q is false, and not P, P is true. So now that the truth values are filled in, let's take care of the negations first. That'll make it a lot easier. So we have false and true, true and false. All right, I think it just froze. Oh, second. Oh my God. All right, so for C, this one's a little bit longer. We have not P and R, or not Q and not P. So we have our true, false, true. So I'm going to fill in the truth values. P is true and R is true, or Q is not Q, that's not false, and not P, so not true. So I'm going to take care of the negations first. That's going to make it look a little bit cleaner. So we have not true is false and true, or not false is true and not true is false. So the negations just switch all of them from true to false, false to true. So I'm going to deal with the parentheses first. False and true makes it false. That's a conjunction. False and true is false. Or true and false. True and false, that's a conjunction. That's also false. And a false or false, this last one is a disjunction. False or false is false. And the last one. So D, we have P and R and not Q. So P is true and R is true and not Q. Q is false. So I will deal with the negation first. So the not false is true. True and true is true. True and true is also true. There you go. So, all right, thank you for watching. I hope this helped. If you have any questions, please ask at the next lecture. Have a very nice week, everyone. Bye-bye.